The next thing we're going to learn is how a catalyst affects an enthalpy diagram, and then how to identify them in reaction mechanisms. This feels a little out of place, but we have to learn about catalysts to fully understand all the parts of a reaction mechanism. So if you'll remember back to, oh geez, what lesson was that? Like 1.6 maybe, or 1.5, where we learned that a catalyst was something that increases the rate of reaction by lowering the activation energy, which meant that more molecules have the minimum energy required to have a successful collision. So how catalysts affect reactions, they provide an alternate reaction pathway with a lower activation energy. So only the activation energy changes so that more molecules have the minimum energy, more products are formed per unit of time, so the reaction rate increases, and this would apply to both the forward and reverse reactions. But the things that don't change would be the potential energy of reactants and potential energy of products. So the delta H would remain constant. But you'll see here with the catalyst, right, it's a lower activation energy than it is without the catalyst. The key thing here is that a catalyzed reaction often involves more steps than your original reaction mechanism, but the highest energy barrier would be lower, which would make it faster, right? And again, the catalyst does not change the potential energy, so the delta H remains the same. Only the route between the reactants and the products is on, or only the route between the reactants and products is changed. And again, super emphasizing that the uncatalyzed reaction will still occur, right? Even when a catalyst is present, but it is a much slower rate. And so you're having some product produced from that original uncatalyzed reaction, but then a bunch of your reactants are also going to go through the catalyzed reaction and you get more product. So just a quick multiple choice question. How does the addition of a catalyst increase the reaction rate of an endothermic reaction? Does it reduce the delta H of the reaction? No. Does it increase the delta H of the reaction? No. Right? Does it provide an alternate lower energy pathway? Yes. It does not cause the reaction to become exothermic. Awesome. Okay, a couple more just quick questions. Consider the following potential energy diagram for an uncatalyzed and a catalyzed reaction. Which of the following describes the forward catalyzed reaction? So the catalyzed reaction is the one that has the lower activation energy. So it would be this little bump in here, which you can see has an activation energy of 10 kilojoules. So the forward catalyzed reaction has an activation energy of 10 kilojoules, not 25. And then what is the enthalpy? Well, the enthalpy change is a step down. So this 15 kilojoules is being released, which would make it negative 15. So the answer to this question would be A. Now, when we're looking at a catalyst in a reaction mechanism, the key difference is that it's going to be introduced into your system. So it's going to be introduced as a reactant, but then it's going to leave later unaltered as a product. So it's different than a reaction intermediate, which is produced and consumed. This is something that you're adding in and then it comes out later. So it's going to appear on the left and come out on the right. Another option is sometimes they'll just write a catalyst over the arrow in the reaction. But just like the reaction intermediate, it does not appear in the overall balanced equation. So here's a catalyzed mechanism example. We've got H2O2 forming water and oxygen gas. This is a very slow, uncatalyzed reaction. Consider the following reaction mechanism and overall reaction after we add some potassium iodide, right? Which potassium iodide would be the aqueous solution, which is really providing potassium ions and iodine ions. Okay, so if you look at this reaction, you've got your H2O2 plus I minus going to H2O plus OI minus, and then H2O2 plus OI minus going to H2O plus O2 plus I minus, so that your overall reaction is that two H2Os, 1, 2, are combining to form two waters, 1, 2, and an oxygen gas. There it is. Okay, So all of those are reactants and products. Everything else is either a reaction intermediate or a reaction intermediary and or a catalyst. So how do we tell which one's which? Well, we've got this iodine. So we've got this iodine ion that came in with the potassium iodide. It's introduced into the system as a product or as a reactant, but then it comes out later as a product, which makes the iodine ion a catalyst. How can you tell? Well, it's introduced as a reactant and comes out as a product. Whereas if you look at this OI minus, it is a product first, and then it is later consumed as a reactant, which would make this one a reaction intermediary or a reaction intermediate. How do you know? Because it first appears as a product and then it is later consumed as a reactant. Just a little side note, a little biology connection is that enzymes are often act, or not often, enzymes act as catalysts, period. What happens is that enzymes are a type of protein that have an active site that holds specific molecules that they are catalyzing, which are called a substrate. And so, if you've ever taken a biology course, you'll often see something like this, right? And so then you'd have this substrate that's sitting in here, and it's almost like it's just helping with the alignment of your reaction. And so it's going to hold the substrate and it's going to speed up the reaction. So this I showed, well, A, to make a connection to biology, and B, I just wanted to show you, this is an example of showing a catalyst. So you've got this maltose plus water forming glucose, and then the maltase, which is written above the arrow, would be the catalyst of this reaction. Catalysts are often our biological enzymes. Catalyze when their biological enzymes often end in the suffix ase. So like a maltase or a lactase or something along those lines, and then they can be shown in a reaction. All right, so now you can go and practice the questions to do with catalysts.